You've probably heard this term digital twin being thrown around, but what does it actually mean? Well, it's way more than just a fancy 3D model. We're talking about a seriously revolutionary technology, one that's creating living, breathing, virtual copies of our physical world. And it could be anything, from a single jet engine to an entire city. But the whole idea got its start during one of the most nail-biting moments in the history of space exploration.
Okay, picture this. You're 200,000 miles from Earth. An oxygen tank explodes. Your spacecraft is dying. That was the nightmare facing the Apollo 13 crew. But back in Houston, NASA had a secret weapon, a very early version of a digital twin. They had simulators on the ground that mirrored the crippled spacecraft in real time. This let them test out crazy, desperate ideas and figure out solutions before telling the astronauts what to do. It was the ultimate proof of concept. Solve the problem in the virtual world to save lives in the real one. Now, that was decades ago. And today, that basic idea has evolved into something incredibly powerful. So let's nail down a clear, modern definition of what we're talking about.
The key phrase here, the absolute magic of it, is updated with real-time data. This isn't a static blueprint you look at once. No, this is a living model. It's constantly being fed data from sensors on the real thing. So think of a virtual factory where you can see the live status of every single robot right now. It's not a picture, it's a mirror.
So this all sounds incredibly cool, right? But what's the point? I mean, why are some of the biggest companies in the world pouring billions into building these virtual copies? Well, the answer comes down to some absolutely staggering gains in speed, efficiency, and, well, just getting things right.
Let's start with speed. Get this. Wistron, a huge electronics manufacturer, needed to simulate airflow in its factories. This used to be a 15-hour job. 15 hours! By using a digital twin, they got that time down to just 3.6 seconds. That's a 15,000 times speed up. That's not just an improvement. That completely changes how they can work.
Okay, what about efficiency? When a company like BMW Group wants to build a new factory, they now build the entire thing in the virtual world first. This digital twin lets them play with the layout, test workflows, and optimize every last detail before they even break ground. The result? They're looking at a 30% jump in planning efficiency. That is huge.
And quality? This is where it gets really interesting. Pegatron, another big manufacturer, uses digital twins powered by AI to inspect for defects. These virtual models, which have learned from tons of real-world data, catch 60% more defects than human inspectors. It's this perfect combination of human skill and AI precision.
So you see, the big takeaway is this. Digital twins let you design better, run millions of what-if scenarios with zero real-world risk, and tweak things on the fly. All of this, of course, leads to massive cost savings. And, as we're about to see, this ability to test things safely in a virtual world is becoming the foundation for the next wave of AI.
All right, I know this can feel a bit like science fiction. So, how is it actually possible? What are the magic ingredients that let us build these incredibly detailed, real-time virtual worlds? It really comes down to 4 essential pillars.
First, you need a common language so all the different 3D design files can talk to each other. That's OpenUSD. Next, you need a simple way to ask questions and understand all this complex data, and that's where generative AI comes in. Of course, you need the world to not just look real, but to act real, with perfect physics. That takes state-of-the-art computer graphics. And finally, to run these massive, complex simulations in real time, well, you need an incredible amount of horsepower, and that's accelerated computing.
You know, to really get why that first piece, OpenUSD, is such a game changer, just think about the early internet. It was kind of a mess, right? A bunch of different formats that didn't work together. Then HTML came along and created one standard for everything. OpenUSD is doing that exact same thing, but for the 3D industrial world. It's the universal translator that lets everything connect seamlessly inside a digital twin.
Okay, so we've got the what, the why, and the how. Now for the fun part. Let's take a lightning tour of where this tech is already making a huge difference out in the wild.
In manufacturing, companies like Foxconn and Continental are building digital twins of their entire factories. They can test a new layout, simulate a new production line, or train a new robot, all in the virtual space. This means when the real factory gets built or updated, it's already working at peak performance from day one.
For self-driving cars, digital twins aren't just a nice-to-have, they're essential. You can't just have a new AI learn to drive by crashing on a real highway. It's not going to work.
Instead, that AI can drive millions and millions of miles inside a super realistic simulation, facing every crazy weather pattern or traffic jam imaginable, all in total safety.
And the impact in healthcare is just wow. Surgeons can now take a patient's MRI and CT scans and build an exact digital twin of their brain. This lets them rehearse a really tricky surgery, like removing a tumor, over and over again on that perfect virtual copy before they ever touch the patient.
And the scale of these things can be absolutely mind-blowing. NVIDIA's Earth 2 platform is literally a digital twin of our entire planet. The goal is to simulate our global climate at an insane resolution to help us get way, way better at predicting and preparing for extreme weather events. And bringing it back down to Earth, city planners are using digital twins to test new subway lines, figure out better traffic light patterns to get rid of gridlock, and even simulate emergency situations to find the absolute fastest routes for ambulances and fire trucks. So this stuff is already here, and it's already having a huge impact. But where does it go from here? Well, the future of digital twins is completely tied up with the future of AI itself.
See, the next big leap for AI isn't just about language or images. It's about interacting with the physical world. We're talking about robots in warehouses, drones that inspect bridges, AI that manages a power grid. But before you can let these physical AIs loose in the real world, they need a safe place to learn. The digital twin is that place. It's the virtual sandbox where the AIs of tomorrow are being born and trained today.
From saving a single spaceship to simulating our entire planet, the potential here is just vast. It really makes you think, right? If you had this technology in your hands, what part of our world, what system, what process, what place would you build a digital twin of first? And what problem would you try to solve with it?